Hello everybody. This is a planetarium show which will take us through the objects that you can see in the night sky for April of 2020. And I've put it together using the Planetarium software, which is an excellent tool for looking at what you can see at different times in the night sky, and it's free to download from the internet, so it's called Planetarium. Well, let's get started. So at the moment we've got blue skies and the sun in the sky here above the horizon, and I'm going to let time run forward and we'll see how the sun moves down towards the horizon and the sky is going to start to darken for us. We'll get those classic orange colours of sunset as the sun nears the horizon, and of course eventually it'll be dark enough for us to start to see the first stars. So here we go, the sun's just about to dip below the horizon there, and we'll bring it to a halt just as it's starting to get dark. And then we'll go and look at the most obvious object in the sky at the moment, and that is the planet Venus. Venus is very, very bright indeed up here in the west, and with a telescope or a pair of binoculars you can zoom in on it, and the Planetarium software can take us right in, and you'll see the just under half lit side of Venus there. The day side is pointing down and to the right towards the sun, and you'll see that lit up. You won't necessarily see the dark side, the night side of Venus. That's just shown so we can see where the whole planet would be. Now normally when we look at Venus we don't see anything except for the cloud tops. It's very difficult. The clouds are very thick. The atmosphere on Venus is 100 times as dense as our own. So without sending a space probe, and only a very few Russian space probes have done that and made it to the surface, it's very difficult to study what's going on beneath those immensely dense clouds. So let's pull back away from Venus and we'll get to allow time to run forwards so that the sky darkens a bit more, and we should start to see one or two stars. They're just beginning to become visible as we move forward. We're going to head forward to 9:15 at night, and it'll still be a little bit light at that point. Some of the favourite constellations beginning to come into view. One or two satellites flying across the screen. This software knows about a lot of the major satellites. So here we are, we've stopped at 9:15 at night, and we've chosen that deliberately so that we can look at one or two of my favourite constellations before they disappear down below the horizon. The first of those is going to be Orion the Hunter over here. A classic, easy to find constellation, lots of bright stars, particularly the three that make up Orion's belt there. Just above the horizon we've got Rigel, and directly above it on the opposite corner of Orion is Betelgeuse. So there's Orion the Hunter facing off against his eternal foe Taurus the Bull there in the night sky. And let's have a look at some of the objects that we can find inside that constellation of Orion. So here's Betelgeuse, very red star to the eye. We can see it has been dimming down recently, and there's some speculation that it might explode as a supernova, but it might take another million years. Predicting these things is not an exact science. We can't tell quite what's going on inside the star. So that's Betelgeuse, and it's around 650 light years away from us. So if it does explode at a supernova, it will be very spectacular, but it wouldn't actually be close enough to be dangerous to life on Earth. The most famous object in Orion is the sword handle here, and this is the Great Orion Nebula. It's where stars are being born out of a cloud of gas and dust that is collected together under gravity, and you can see some new stars right in the center there that have lit up out of the densest parts, and they're beginning to blow the bubble of gas surrounding them away and lighting it up with their ultraviolet radiation, making it glow. So that's the Orion Nebula. You can see that without a telescope, but with binoculars or a small scope it's much better. Now we're going to look at Orion's belt, and we're going to zoom in on the left-hand star of Orion's belt called Alnitak. And that's a good place to look if you've got a powerful telescope available, like 8-inch or 10-inch reflecting telescope. You might be able to track down just next to the bright star. You'll see the Flame Nebula at the top of the screen there. And below it, more difficult to find, is the Horsehead Nebula. It looks like a seahorse's head, perhaps. There's a dark, dusty material swirling round in front of the glowing pink of hydrogen gas there. So those are a few of the nebulae in and around that lower part of Orion. There's another cloud of gas, you can already see it, and that's up here. Again, we've got dirty, dusty material passing across in front of a bright star, and then the light from that bright star that we can't see is lighting up the rest of the gas in this cloud from which new stars have been being born in the past. So there's a lot of this sort of star forming process going on in and around the star clouds of Orion. Next from Orion, we're going to look left and down a bit, down towards the horizon and to the brightest star in the sky, apart of course from our sun. And that is Sirius, the dog star. And it's called the dog star. It's the main star of Canis Major, the big dog. There's Orion, and he's got his faithful hunting dog following at his heel there, Canis Major, the big dog. And he's also accompanied by the lesser dog, Canis Minor. And that is these stars up here. Now, it takes a little bit more imagination to try and make a dog shape out of these, especially when the stick diagram is just two stars joined by a line. But the ancient people managed to decide that there was a little dog here somehow, and that's the bright star Procyon. So that's the second of Orion's hunting dogs. Now, in the region between them, there's an even more indistinct constellation, and that's the constellation of Monoceros. The Milky Way runs down between the big dog and the little dog, and this area here hasn't really got any bright stars in it, so they decided to join some of the lesser stars up and make this shape here, and concluded that it looked like a unicorn. And I really wonder quite how they managed to do that. There's the unicorn. Okay, so Orion is going hunting, chasing Taurus the bull there. You can see Taurus's horns with two dogs and a unicorn. But at the nostrils of the unicorn, perhaps representing the unicorn's breath, is the Rosette Nebula. Now, this is a lovely object. You can find this on a dark sky night with a pair of binoculars. You'll see the star cluster in the middle. This is a slightly older star cluster that's formed in the same way as the Orion Nebula, but is a little bit older, and so the stars are prominent and the gas is being blown away. You can see how they've blown a bubble in the middle there. And that bubble, that star cluster right in the center, that's about the same size as our moon appears on the sky. So this is really quite a large object. A telescope won't really show it. You need binoculars for the wide field of view. Just above it is the Christmas tree cluster, and the Christmas tree cluster contains an object called the Cone Nebula. Again, more star forming going on here, young stars being born out of clouds of gas and material. Here's a high resolution image overlaid. You can see all of that gas in and around this triangular shape which makes up the Christmas tree cluster. So a couple of interesting little objects to go and chase down there in that region of Monoceros that lies between the two hunting dogs. Now let's pull back away from there and we'll see a bit of a wider view of what's going on. Just see the top of Orion, and over here is Taurus. We've got that V shape with the one bright star making up the face of Taurus the bull. It's got the two enormous horns going right up there towards the top of the screen, and the other bright object there is of course Venus. We can see Venus is right by one of Taurus's ears. His eye there is Aldebaran. It's the reddish orange coloured star, a giant star at the end of its life. It's swelled up. This happens when stars are beginning to run out of fuel, and it marks the position of the eye. The other stars in the cluster there that make up the face are a bit further away and are a star cluster called the Hyades. On the back of Taurus the Bull, we've got this other cluster called the Pleiades, though, the Seven Sisters. And these are very young stars. Perhaps this cluster is a little bit older than the Rosette Nebula and represents the next stage on. Almost all of the gas has been blown away, just leaving a naked cluster of stars, about 150 stars there. And that's easily visible without a telescope. Even with the naked eye, you can see it as a fuzzy patch in the sky. Binoculars show it really well. More challenging to find, up by the horns of Taurus, is the exploded star remnant, a supernova remnant called the Crab Nebula. Here, a star blew up and was observed by Chinese astronomers in the year 1054 AD. They saw it as a bright new star in the sky for about 3 months. It was visible in daylight even. But now we see the exploded remnants there. So now we're going to move on a little bit further into the night and a little bit further around the sky and look at some more objects. So we're going to pull back and then we'll let time run forwards, and we'll move on from 9:15 to later in the night at around about midnight, and look at this part of the sky over here. I can already see the outline of another very famous constellation, that's Leo the Lion. 1 or 2 satellites whizzing past, but I'm just going to let time pass and we'll get this positioned perfectly so that I can show you the objects that I want to. When we're looking in this direction in the sky towards Leo, we're looking out into deep space, away from all of the interference of the nearby star clouds in our galaxy. And so this is a great place to go looking for other galaxies. You can go galaxy surfing through Leo. And the first group we're going to look at, there's Leo the Lion. It really does make a lion shape in the sky, doesn't it? But we're going to take that away, and we're going to look at a group of galaxies just below the belly of Leo. And this is called the Leo Trio. There are 3 galaxies really close to each other. Different shapes and sizes of galaxies there, look. And they've got these numbers, M95, 96 and 105. Those numbers refer to their catalogue number in a list of objects that was compiled by Charles Messier, a famous French astronomer. One that he missed is this one. This is the Catherine Wheel galaxy over by the nose of Leo. And this one's quite easy to find as well. It's quite bright, and it's got these lovely spiral arms and a slight bar structure across the middle so that it's more elongated. And you can see the colour as well. You can see that it's redder in the middle and bluer towards the outside. That's very characteristic of spiral galaxies. So there's plenty more objects like that in Leo. There's several other groups of galaxies for us to look at, but we'll move on, and we'll go and perhaps look at something that you can go and trace with just a naked eye and then perhaps with binoculars. Here's the constellation Gemini, the heavenly twins, and the 2 stars at the top of the stick men there are called Castor on the right and Pollux on the left, and they really do look like a couple of human figures if they're drawn like that, don't they? So there's the heavenly twins of Gemini. Now down by the foot of one of them, just above that tree on the horizon there, with a telescope we can zoom in and find another exploded star remnant. It's only just above the tree here, look, and it's called the Jellyfish Nebula. This is rather older, and we're not quite sure whether it was 3,000 or 30,000 years ago when this one blew up. It can be quite difficult. There's a high-resolution photograph. Afraid we've been photo-bombed by some satellites in trying to take that image, but it shows the colour a little with that sort of orangey colour. So that's the Jellyfish Nebula in Gemini. Now we're going to pull out and move to the right to the pentagon of stars. You can see just up to the right of the tree there, That's the constellation of Auriga, the charioteer. So we'll just position that perfectly and then show you, there's the ring of stars that makes up Auriga. And here he is, the artwork's coming up. And you can see he's carrying some goats, a mother goat and a couple of baby goats. Now the brightest star in Auriga, that's near the face of the mother goat there, is called Capella, and it's called the goat star. And the little triangle of stars that are underneath are called the kids. So here's Capella, got a little bit of a cloud of gas around it, and we'll zoom right in. This star was imaged by a very special telescope called COAST here in Cambridge, which actually managed to show the surface of the star itself rather than just seeing it as a point of light. So that's Capella, and just below it is the little triangle you can look out for of the kids. Now in Capella you can also use your binoculars to go and look at some star clusters, and there are 3 very similar star clusters, but the challenge is to work out which one is the youngest and which one is the oldest. If I tell you that the stars in star clusters gradually get thrown out of the cluster and more scattered over time due to having near misses with each other, and one of the stars then gets a slingshot effect and thrown out of the cluster, you can probably work out from these 3 which one is the youngest and which one is the oldest by the more scattered nature of the stars. They're not packed together as tightly in the middle, but they're all 3 in a nice row there and very easy to track them down with a pair of binoculars. Just a little bit below these 2, we've also got a couple of good targets for a telescope with a camera, and that's because we've got some lovely clouds of gas that show up some amazing colours. Now you won't see the colours with your eye, but you will pick it up with a camera on a powerful telescope, a good amateur telescope, and you can see the Flaming Star Nebula and another pink nebula off to the side there. Here we go, we move over a little bit. And you can really see the nice colour contrast in these clouds of gas and dust that are being lit up by different stars and different processes. The pink is hydrogen that's glowing, and the blue colour is the reflected light of hot blue stars. So different results from different processes. Okay, so we'll pull back away from the star clouds of Auriga, and we'll go and find something that perhaps everybody has recognised, perhaps the most famous constellation of the night sky, and goes by a variety of different names, this one. Some people call it the Saucepan, some call it the Big Dipper, some call it the Plough, but the official name is Ursa Major, which means the Great Bear, and it's a bit higher up. Here it is, we've got the 4 stars that make the Saucepan there. We've gone zoomed in a little bit too much. Let's come back and we'll begin to see the Saucepan handle sticking off the top there, but the whole constellation of the Great Bear is very large indeed. You can see his nose and his paws at the bottom and the tail going up to the top off the screen. I think we'll take the artwork away there and swing him round so that we get a better view. Let's bring that, there we go. Here's the tail of the Great Bear, and we're going to look right into the middle star of the tail. And this is a double star. The 2 components are called Mizar and Alcor, and you can see the 2 separately just with your eye. Don't need any telescope for that at all. But a very powerful telescope, you can zoom right in, and Mizar turns out to be a double star in itself. And in fact, you could do the same on Alcor. It's a double star system, a quadruple system. So that's the tail of the Great Bear. And just below Mizar, we can already see a fuzzy patch on the image there, and that's the Pinwheel Galaxy. So it's a good way to find it, is to start from the tail of the Great Bear. A classic spiral galaxy, 20 million light years away from us, all the way across deep space there. Very much got that same colour of the yellow in the middle. This is the high resolution image that I've brought up, show it in great detail. And we'll take that away again and then zoom out. And we're going to look at another galaxy called the Whirlpool Galaxy, which is the other side of the tail of the Great Bear. And what we find with the Whirlpool galaxy is we can see how galaxies grow in action, because the Whirlpool galaxy here, you can see the spiral structure of it, but you can also see that a wandering dwarf galaxy has come too close to it, and the main galaxy is beginning to eat it for its lunch. Now, this is how galaxies get bigger. They're cannibalistic. They eat smaller galaxies that come too close to them. Their gravity grabs hold of them and pulls them in, and the two systems end up merging, and one galaxy ends up getting larger. So quite an interesting process. Now, a different type of object. This is what the sun will look like in about 5,000 million years. It's called a planetary nebula, but it has nothing to do with planets. It's a dying star. The star's puffed off its outer atmosphere out into space, and left behind, that little dot in the center, that's a white dwarf star. These white dwarf stars are dead stars. They'll eventually cool down and become black dwarfs. They're the dead nuclear heart of the stars. Here's another galaxy for you, and this one's a bit of an edge-on spiral galaxy, so it's a little bit more difficult to see the structure. You can see lots of dirty dust lanes in the spiral arms, carving around, cutting through the brighter middle nucleus of the galaxy there. This is a bit further away, 45 million light years for this one. So we'll pull back out of Ursa Major there and cross the bowl of the plough area there, and there's another pair of galaxies. These two show up very nicely with a modest sized telescope. We have Bode's galaxy and the Cigar galaxy. Bode's galaxy on the left there looks like a traditional spiral galaxy with a bright nucleus and those lovely spiral arms. And these are about 10.5 million light years from us. But about 6 million years ago, the Cigar galaxy, the smaller one, came too close to its larger neighbour, and you can see the disruption and chaos that has resulted. The spiral structure has been somewhat twisted, and all this red material has been poured out of the centre there due to all of the chaos and disruption of this near miss that it had with its larger neighbour. Now we're looking at the little bear, Ursa Minor. It's like a miniature version of the plough with that square and the long tail. And at this point, somebody really ought to be pointing out that bears' tails are not this long. The ancient Greeks got this rather badly wrong. It's more the shape of a fox with a long bushy tail. Bears have rather short tails, but never mind. The tip of the tail of the Great Bear is a very important star to us here on Earth. It's the pole star, Polaris, or the North Star. And it's important to navigators because it sits directly above the North Pole of the Earth. So if you stood at the North Pole, it would be directly above your head. A little bit further south where I'm doing this from, in Cambridge, it's about 52 degrees above the horizon, but it's always in the same place. It's always due north. And as time goes on, we're running time forwards at quite a speed here. You can see that Polaris remains stationary right in the center of the screen, and the whole sky appears to spin around it. There's quite a few satellites whizzing past, but the stars all smoothly spin around as the Earth turns underneath them. Now we can use the Planetarium software to go backwards, so I'm going to return back to midnight. It's like having a time machine. I can control time and go forwards or backwards at any speed I like with this system. So we'll go back to midnight where we were so that everything's in the right place. We'll bring that to a halt. And now we're going to go and look at another couple of interesting constellations that are visible best after midnight. Often that we look at these when we're doing our observing more in the summer, but you can see them all the time. And we'll pull back a bit away from Polaris and then move across down here a bit lower. We've got the constellation of Lyra. This is looking to the north now, and We have a parallelogram of stars with one separate bright star. Now, the ancient Greeks decided this was the shape of a Greek musical instrument called a lyre, and probably not familiar with that. I know I'm not, but I really can't see that that fits that shape very well either. So we'll take that away, and what we're going to do is look at the bright star Vega. This is one of the sun's near neighbours. It's only 25 light years away, which is why it looks so bright to us. But it is a bit bigger and heavier, more massive than the sun, and hotter, 9,000 degrees. The sun is only 5,500, and Vega puts out about 40 times as much energy. The bigger and more massive a star is, the faster and hotter it burns. So we're going to zoom in now and look at one object that's inside this little constellation. That's one of the real most impressive sights of the all the night sky, and that is called the Ring Nebula. Here it is. We're zooming in, and you see a ring, a smoke ring in space with a red tinged outer envelope and a white dwarf star right in the middle there. This is again the end stage of a sun-like star, where it's puffed off its outer atmosphere, blown it out into space, and left the dead nuclear reactor in the middle there. And that's what our sun is going to do, as I said earlier, in about 5,000 million years. So there's plenty of time. So that's the Ring Nebula. Now we're going to go to the constellation of Hercules. You can see this sort of keystone structure of the four main stars in the middle there, with the arms and legs of Hercules stretching out away from it. Now, Hercules turns out to be upside down. His head's at the bottom there, look. But a lot of things in astronomy tend to be upside down. We just need to not worry about it. I've chosen to stop here on our tour because there's a different type of star cluster in Hercules, and it's very easy to find. You can just about find it with the naked eye, but binoculars will show it up, or a small telescope, and it's the Great Globular Cluster. It's about 25,000 light years away, just outside our own galaxy, and there's 500,000 stars. Here's the high resolution image. These 500,000 stars packed together in a tight ball, and we think that there's probably a small sized black hole in the middle there, maybe about 30 times the mass of our sun. Here's another globular cluster, slightly smaller, a little bit further away, and these are like micro galaxies that are all buzzing around the outside of our Milky Way. We have something like 400 of these globular clusters, and they might be the remains of small galaxies. They might be the nuclei of very small galaxies that the Milky Way has tried to eat. We're not quite sure, but they're very, very common, and also very beautiful to look at if you do manage to image them with a telescope. They look like jewels scattered on the velvet background of the black of space. Very lovely indeed. Okay, so now we're going to move on to the dawn sky. We're going to go traveling through time to 4:40 a.m. and the reason for that is that we've only looked at one planet so far. That was the planet Venus at the beginning of this tour, and the three main planets that I'm going to show you are all queued up in the dawn sky right before the sun comes up, just best viewed at exactly 4:40 a.m. So we'll let time whiz around. There's a bit of the Milky Way there coming up, and we'll traverse over to the east towards where the dawn is going to come from and see what we can find. It's Vega in the middle of the screen, just to the left there, but down here, just rising up above the horizon, we've got the moon there, but we've also got the red planet Mars. We zoom in on Mars, we see that it's showing a 3/4 lit face towards us at the moment, and it's got its two little moons there, which you won't see unless you've got a very powerful telescope, because they're ever so tiny, Phobos and Deimos, fear and terror, to go with the Mars being the god of war. Now we can zoom in a bit on Mars and just about make out some surface features there, the different light and dark markings, and that ring shape, that light ring shape, that's a volcano on Mars up at the top there. Mars has some very large volcanoes indeed, and that one is Olympus Mons, the largest volcano in the solar system. It's about the whole area of the country of France. It's huge. So that's Mars there, just above the moon, very easy to identify. And there's two more planets there laid out for us. And I said there were 3 in a row. It's quite striking at the moment. They're all very bright and just in that dawn sky. But before we look at the other two, here's the constellation of Sagittarius, the Archer. Personally, I don't see an archer. What I see is a teapot. And I do wonder how they managed to make a man with a bow and arrow on a horse here, but never mind. Now, Sagittarius, just above the horizon there, contains some very, very dense star clouds, partly because we're looking at the Milky Way, at the densest part of our galaxy, towards the center of the Milky Way. Here's the Eagle Nebula. And this was photographed by the Hubble Space Telescope. You might recognize the pillars of creation in the center of the Eagle Nebula. It was a very iconic photograph that the Hubble Space Telescope took of this right in the center here, showing how these pillars of gas had formed. This is the Swan Nebula. The brightest bit is the body of the swan. Below that is the wing, and then you've got the neck and the head. It's a little difficult to make out, partly again because it's upside down in this image. Just below the Swan Nebula, we've got the Lagoon Nebula. And this is quite bright, actually. You can easily see this with binoculars. You probably won't see the colour unless you've got a powerful telescope, but it does show that very bright pinky red colour of hydrogen gas, and a lot of new stars that have been formed in this region where the gravity's been pulling the gas and dust together again. Just next door is the Trifid Nebula, and there's some dark dust lanes running across in front of the lit up gas, and a mixture of colours. We've got the pink of hydrogen and the blue light being reflected from a couple of blue supergiant stars there. So very good colour contrast in that one. So let's pull back away from the star clouds of Sagittarius, the Archer, and I promised you we'd go and look at the planets, so let's go and look at Jupiter next. Jupiter, the largest planet in the solar system. It's 2.5 times the mass of all the others put together, but it's still only 1/1000th of the mass of the Sun, so it just goes to show how big the Sun really is. Here's Jupiter. As we zoom in, we'd get the view from binoculars or a small telescope with the disk of the planet and a couple of prominent cloud belts there, plus the 4 large moons that were discovered by Galileo. Nearest to Jupiter is Io, then Europa, then Ganymede, and Callisto orbits the furthest away of the 4. If we zoom right in on the planet, we can see those cloud belts in more detail. And over to the right center, you can see the great red spot. That's about 3 times the size of the Earth. You can also see some white spots. Again, all these spots are storms within the atmosphere. And that great red spot has been raging ever since Galileo 400 years ago first looked at Jupiter with a telescope. So it's been going a long time. Let's have a look at Io. You can see the yellow color of it already. But when we zoom right in, we can see why it's yellow. Turns out that it's absolutely covered in volcanoes. Every one of those black dots and black splodges is an active volcano on Io, and they've been spewing sulfur all over the surface. It's active all the time. Pulling back from Io, we're going to go the other side of Jupiter, and we'll take a little look at the second moon, Europa. Io and Europa are about the same size and about the same size as our moon. But Europa is covered in shiny white ice with grooves and cracks. And some of those cracks are bringing dirty, ruddy brown organic material to the surface. We think there's an ocean underneath that ice, and it may even be that there's some form of life down there. We don't know. The third moon is Ganymede. Now, Ganymede is a larger moon. It's actually the largest moon in the solar system, bigger than the planet Mercury. So if this orbited the Sun, we would definitely call it a planet. And it's covered in ice, and there's a few craters, but there's a lot of activity been happening on the surface of Ganymede recently. And again, we think there might be an ocean underneath some of that ice. So it's a little world that we're planning to investigate in more detail. And the fourth moon of Jupiter, the one that orbits furthest away, is Callisto. And Callisto is covered in craters and is much darker. It's about the same size as Ganymede, just a tiny bit smaller, but still larger than the planet Mercury. So a planet-sized moon in its own right. So we'll pull back away from Jupiter and its moons, and then we'll swing left a little bit and find Saturn. Now, Saturn is an absolutely magnificent sight in a telescope, and was the first object I ever saw through a telescope, and I was absolutely hooked on astronomy, as you can probably tell, ever since. So it's something like 45 years ago, I turned my eyes to a telescope and saw the rings of Saturn like this for the first time. And of course, you can see a collection of moons there. The more powerful your telescope, the more moons you can find, because they're all different brightnesses. And you can pick up Titan there quite easily. Let's zoom in a bit more on the planet itself, though, and show you that in more detail. So we can see the belts, the cloud belts on the planet there, looping around it, and a magnificent set of rings. The rings are made of millions and millions of individual particles, all orbiting around Saturn, and probably result from the disruption of a moon or a comet that came too close, and the gravity of Saturn tore it apart. Here is Titan, again another planet-sized moon, and this is covered in a thick atmosphere, and that atmosphere is about 50% more dense than our own, and full of these smoggy orange clouds that contain all sorts of interesting organic chemicals, perhaps the signs and the seeds of life on Titan, although it's a chilly minus 160 degrees on this little world, so maybe that might present a bit of a problem. So that was Saturn. Now we're just going to finish off this planetarium show for you with a quick look at the moon. And the moon is just rising at 4:40 a.m. This is set for the 15th of April, and it's a very accurate simulation of what you would see. Look, on a different night, the moon will be a little bit different, but the rest of things won't have changed very much. You can see the seas of the moon and one or two prominent craters there. Now, if you want to know more about the moon, go and look on YouTube and find my video of the moon, which is in 2 parts. Got some absolutely magnificent photographs and a lot more detail about the moon in it. And indeed, look at the other videos that talk about the planets and the life and death of stars, and there'll be more videos turning up there as we go along. So what I'm just going to do to finish this planetarium show off is move up and look up at the sky and the stars up in this region here, and we'll just then let time run forward, and the sky will brighten because the sun is almost immediately coming up, and so the stars are going to fade away and disappear completely for the start of another day. 1 or 2 satellites whizzing around there. I think we see the International Space Station at some point in this presentation, but we'll talk about that another time. So there we go, that's the end of the show. Thank you very much.